section 10.4. In this section, we're going to be talking about something called compound events, which basically is what it sounds like. It's basically two or more events that are happening at the same time. And some new terminology that you'll be kind of seeing in this is one that's called sample space, which is, again, a set of all possible outcomes of one or more event. Then we have something that's called a tree or a branch diagram, depending on how you were taught. I was actually called a branching diagram, but I've also heard it called tree. I think tree is probably the more commonly used. And it looks kind of like this, is I start off with two stuff and things, and that leads to more stuff and things, and that ends up leading to even more stuff and to even more things. Basically, think of it like this. A tree diagram is basically kind of the family tree. You have an object and it just keeps adding on more and more. And it's easier to show you how this works than it is to verbally explain it. But anyway, you'll get the point in here in just a minute. Lastly is something that we're going to be calling the fundamental counting principle. It's basically the mathematical way of finding possible outcomes. And I just wrote a little note here. We just multiply the events. And again, this will make more sense as we go along and do a couple problems together. So, in regards to terminology, I'm not too worried about this. Just be aware that you're going to see sample space used a lot. Basically, it's just asking you what are the possible outcomes. All right, so let's go ahead and get to this. Here I have a little menu on the side of some pizza. So I have crust. I can choose thin crust or stuffed crust, and I can decide my style: Hawaiian, Mexican, pepperoni, and veggie. And the only thing I really see that I want is that pepperoni. But anyway, besides the point. So these are my options here. And it says, I randomly choose a crust and a style of pizza. Find the sample space. How many different pizzas are possible? So what I'm going to do is a compound event here. My first thing is let's call this event 1. All right. And my first event 1 is to choose the type of crust that I want to use. Well, I have two possible crusts. I can use thin or I can get stuffed. All right. And that's my first event. My second event, event 2, happens to be the type of style that I want. All right. So what are my possible styles? I can choose a thin crust with Hawaiian. All right. And I'm going to use the letters for the sake of writing. I could also choose a thin crust with Mexican, a thin crust with pepperoni, or a thin crust with a veggie. So that would be my second style. Or if I choose stuffed in the first event, I could have a stuffed crust with Hawaiian, a stuffed crust with a Mexican, stuffed crust with pepperoni, or a stuffed crust with a veggie. So what this means is that I can have 8 different possible pizzas: a thin Hawaiian, a thin Mexican, a thin pepperoni, a thin vegetable, or a stuffed, I'm going to put S now, stuffed Hawaiian, a stuffed Mexican, a stuffed pepperoni, or even a stuffed vegetable. These are 8 possible outcomes, and these are the specific outcomes that I can have based upon this compound event. Now, what if I didn't want to do all the work here and I just needed the number 8? Well, this is where that fundamental counting principle, it says multiply the events. So look, in my first event, I have 2 possible outcomes. So I'm going to write that down. And in my second event, choosing the style, I have 4 possible outcomes. If I just multiplied those numbers, I would find out that I have 8 outcomes. The problem with the fundamental counting principle is this. It gives me how many that I have, possible outcomes, but it doesn't tell me what I have. So you're going to have to be able to do both of these things. If I want to know you to list all the possible outcomes, the easiest way for you to do it is this tree method. And you can get all 8 of them. All right, but if all I'm worried about is the number, then the easiest thing for you to do is just to multiply the events. And that's pretty much straightforward. All right, so let's do a couple more. It says, use a tree diagram to find the total number of possible outcomes. Why don't you try this one on your own and see how you did? So you may have something that looks similar to this or maybe even slightly different, but you should have had a total of 10 possible outcomes. I could have got a twin size bed sheet that's either a solid or a pattern, a twin XL solid pattern, full, and so forth, so on. So there would be a total of 10 different possible outcomes for this. All right. Number 2, it says, use the fundamental counting principle to find the total number of possible outcomes. In this particular one, I'm going to buy, apparently I'm looking at getting a picture, and I can choose size, finish, or edit. So let's look at size and look at all the possible outcomes of choosing size. I can get 1, a wallet, 2, a 4x6, 3, 5x7, 4, a 8x10, 5, 11 by 14, or 6, a 16 by 20. Let's double check my math. 1, 2, 3, 4, 5, 6. So there are 6 possible size variations that I could get. There are 2 types of finish, matte or glossy. All right, and then lastly, I have the choice of 3 different types of edits, red eye, black and white, and crop. All right, now that I know that, I can actually multiply these numbers together real fast. I can say 6 times 2 times 3, and I get that there are a total of 36 possible outcomes. But again, the problem with doing it this method is I don't know what those outcomes are. I don't know them right now. So if I wanted to do that, the best thing for me to do is to do a tree diagram to find out all possible true outcomes. Why don't you try number 3 on your own? All right, so for number 3, it was asking to choose a hard drive, a style, and a color. You should have got that there was about 42 possible choices that you have in front of you. Now, let's go on to 4, 5, and 6. It says in this, you spin the spinner, which is right here, and you flip a coin. Find the probability of the events. Spinning a 2 and flipping tails, spinning a 7 and flipping heads, not spinning a 4 and flipping tails. So here's the issue with this particular one. I can use that fundamental counting principle and I can find out how many possible outcomes I have, but it really doesn't help tell me the type of outcomes that I have, like I've said before. So I want to do both of them in this particular thing, and it's going to help us with these problems. So let's find out first. It says I'm going to spin the spinner, and that means that there's going to be 5 possible outcomes just on spinning the spinner. And it says I flip a coin, and we know coin is 2-sided. So if I were to do this, it means that I have a total of 10 possible outcomes. All right, but what are those outcomes? Well, I can kind of do my tree diagram on this side right here, and I can write it down the side. I'm going to go 1, 2, 3, 4, and 5. This is my first event. This is my spinner. And then after I spin, I would flip my coin, and I can get a possibility of heads or tails in each and every one of these. All right? So what are my possible outcomes? Well, I can get a 1 and a head, a 1 and a tail, a 2 and a head, a 2 and a tail, a 3 and a head, a 3 and a tail, a 4 and a head, a 4 and a tail, and a 5 and a head, and a 5 and a tail, which when we count this up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, matches what we came up with our fundamental counting principle. So we have 10 outcomes, and here are those outcomes. Now that we know this, let's go ahead and look at our questions. Find the probability of the events, spinning a 2 and flipping a tail. Well, spinning a 2 and flipping a tail, I have 1 chance of getting that out of 10. And that's it. And I can change this to a percentage to be 10%. That's it. The next one says spinning a 7 and flipping heads. Well, look at our spinner. It doesn't even have a 7 up here. So there's no way I could spin a 7. So the probability of this is 0. It's 0%. It's impossible because there is no 7. The last one says, not spinning a 4 and flipping tails. All right, so first off, we need to find out all the ones that are not a 4, but they are tails. So we have this one, that's not a 4 and it's a tail. We have this one, not a 4 and it's a tail. We have this one, not a 4, and we flip tails. We cannot do this one because it's a 4. And then we can do this one, which is a 5 and a tail. So what do we have? 1, 2, 3, 4 possible ways of not spinning a number 4 and flipping a tail out of 10 possible outcomes. We can reduce this fraction to 2/5, or we could say that this is 40%. So I have a 40% chance of not spinning the number 4 and flipping a tail at the same time. And this is basically what compound events are. It's just finding out all the possible outcomes and doing just checking things out. Easiest way to get is use the fundamental counting principle, but it doesn't help you when we get to questions like this that it wants me to be more specific in my answer, so it's better for me to write it all out. So it's a combination of being able to know how to do both. And that's it for this video, and I will see you in the next one. Bye-bye.